So in chapter 8, we're going to start our hypothesis testing. So a big and important phase in this course where we start moving from describing things to making inferences, trying to predict things or test things. Now the testing that's going to be done is going to be claims about a population parameter. So maybe you can remind me of a few things here. What's the population parameter that we use, or the symbol that we use for a mean? What's the population mean denoted with?
Mu.
Mu, excellent. Population proportion, that's a P. How about the standard deviation? What do we use to denote the standard deviation? Anyone? Another Greek letter here.
Is it sigma?
Yes, well done. Thank you. So you've got the mean, the proportion, standard deviation. In section 8.2, we'll start working with testing claims about the population proportion. But before then, I've got to bring you up to speed on some notation. So the first thing is the null hypothesis, H sub 0, or sometimes it's called H naught. You know, it all refers to the same thing. But the null hypothesis is kind of like what happens in a jury trial. In a jury trial, you're assumed innocent until proven guilty. The null hypothesis is assumed to be true until you prove it's not true. So that's going to be assumed true. Now, one thing about the null hypothesis is that it always contains the condition of equality. Always contains the condition of equality. And what do I mean by that? I mean that there's a less than or equal to, an equal to, or a greater than or equal to as part of this statement. And we're going to have to write that statement in symbols, but one of those symbols is going to be one of those three. It has to be. That's the way we construct our null hypothesis. Now, depending on the source, if you're in this class, a lot of times I'll use HA. The author uses H1, but it means the same thing. This is going to be your alternative hypothesis. Alternative hypothesis. Okay. And this is your conclusion if you reject the null hypothesis. If you were somehow able to convince yourself that this isn't true, then this would be your conclusion. So this is our conclusion when we reject the null hypothesis. Now, the way we're going to set things up, one or the other of these things has to be true. So we'll work on some of these as examples in terms of setting up a null and alternative hypothesis. And then we'll move on and discuss other little nuances about these hypothesis tests. But for now, let me turn to something that should be on your handout. I believe I sent this out yesterday. And that is this one. Basics, you know, I guess we can do it right here. So it says, this is our claim. A majority of adults would erase all their personal information online if they could. A software survey of 439 randomly selected adults showed that 64% of them would erase all their personal info. We're going to use this to answer the claims below, answer the questions below. So the first thing is to express the original claim in symbolic form. Let me help out by directing your attention to the important parts here. And let's see, does that make it any bigger? Maybe not really. So the important part here, it says a majority of adults. Now our claim is going to be something that includes either mu, p, or sigma. Now you have to look at the claim. Which parameter does it feel like you're testing? Are we testing a mean, a proportion, or a standard deviation if we're talking about the majority of adults? Well, can we eliminate something? Can we eliminate standard deviation? That we're not talking about the standard deviation here?
Yeah.
Yeah, I think we can eliminate that one. So let me call this example A here. Example A. And we're going to do H sub 0. Oh, actually, no, not yet. Sorry, not yet. We're just going to work on the original claim here. So our original claim. Well, all right, so we've eliminated the fact that it's not a standard deviation. Do you think the majority of adults, is that something reflective of a mean, or is that a proportion? What's it sound like?
Proportion.
Yeah, it sounds like a proportion. Thanks, Megan. So the original claim is that P, it's about a proportion, I agree with that. But what would constitute a majority? What percentage constitutes a majority? There's an election going on as we speak. If you were going to win a majority of the votes, what percentage would that be? It starts at what?
More than half.
50.
More than 50%. Good. So our original claim is this. P is greater than 0.50. It's greater than 50%. It's more than halfway. Now to turn that into a hypothesis test, we first got to decide, well, where does this go? And the thing to keep in mind always about this is when you're working with a hypothesis, H naught has to have the condition of equality. It has to be part of your claim in order to be part of the null hypothesis. Does this have the condition of equality?
No.
No. So that's going to go into the alternative hypothesis. It can't be part of the null hypothesis. So P is greater than 0.50. Now your null and alternative hypothesis function kind of like heads and tails, male and female. So you're one or the other. Now, if this is the alternative, what would be the opposite of that? If you're not greater than 50%, then you're
Less than.
Less than.
less than 50%. Except there's one thing. The null hypothesis is supposed to have what in it?
Less than or equal to.
There you go. Has to have the possibility of equality. So we'll put a less than or equal to. Now, I'll give you a heads up. I like putting this here, less than or equal to, because it makes it very clear that you've got heads and tails. But I think not WebAssign, but my math lab would actually just put P equals 0.50. So just a little heads up. I think the author does some of that kind of stuff too. I like doing this because I think it's more user-friendly, to be honest. But anyways, that's what we're looking for, is just to set up the null and alternative hypothesis. If you want to leave a little room near here someplace, I might come back and look at this a little bit. But right now, that's it. We're looking good there. We set up our first hypothesis test. Comments on the first one? All right.
So when we're answering the question, that's literally all you're looking for. No type of calculations, really just setting up the problem.
I'm afraid so. But don't worry, I'll make them harder. Trust me.
No, this is perfect.
I know. Yeah, I know you're worried that like no, come on, Professor Parent, this is too easy. But yeah, that's what you're gonna get. Now this is just copied from your homework. So you pull a drop-down menu, it choose the parameter, and then you choose, less than or equal to, greater than equal to, not equal to, et cetera. You choose which symbol, and then you type in the value. So you're just gonna enter in that information except with a little use of a menu. And then you're going to do that same thing down here for your null and alternative hypothesis. And that's it. So yeah, that's all there is for the first one. But we are going to build on that though, Jess. So let me keep going with the next one down here. The mean pulse rate and beats. How come that's weird? I don't know what's going on with that. Let me try this again. Maybe a different color here. Stop that. That's so weird. All right, so let me just shade it this way. I have no idea why that's doing that. There. Okay. No, that's not it. Yeah, here, we're okay. So we'll view it from here. So this is example B. Example B. And we're going to do the same thing. We're going to start out with the original claim. Now, the original claim here is that the mean pulse rate in beats per minute of adult males is equal to 68.8 BPM. So, all right. Let's work on our original claim. Come back here. What parameter am I using here? What should be part of my original claim?
Mu.
Mu. Thank you so much, Aiden. So it's going to be mu, and then is equal to 68.8. It sounds kind of high to me, but whatever. Mu is equal to 68.8. All right. Let's look at part B. Mu, because we're talking about a mean, equal to, that came right from the problem, so did the 68.8. For part B, we're going to set up HO and HA. So HO, well, you want to look back here and decide, what am I going to do with this? Is that going to be part of my null hypothesis or alternative hypothesis?
Your null hypothesis, because it's equal.
Perfect. That's going to be in your null hypothesis because it contains a possibility of equality. Yes. All right. So thank you, Megan. Somebody want to fill in the alternative? If this is our null hypothesis, what would be kind of the opposite? What's the opposite of equals 68.8?
Less than or equal, or more than or equal to?
Well, we can't have the equal to part because that's not part of it.
Would it be
Does
negative?
not equal.
Not equal.
Yeah, let's go with not equal. So not equal 68.8. And again, if you're entering this stuff on my math lab, then you're just going to use the drop-down menu to choose the parameter and then choose a symbol and then type in this part. So I'm hoping that those are a few quick, easy points for you on that kind of stuff. So are we okay there? Let's try one or two more. So example C. And again, we'll go back to that handout that you should have gotten on your student email. I've highlighted for us the stuff that's important here. The claim is that the standard deviation of pulse rates of adult males is less than 10 beats per minute. So like the last couple, we're going to state the original claim and then decide the null and alternative hypothesis.
So would it be sigma is less than 10?
Okay, so we got sigma is less than 10. Do we agree with that part? Sigma, because you're talking about the standard deviation, less than 10 comes directly from the problem. Yeah, looks good to me. Somebody else that hasn't had a chance to speak up today. What hypothesis should this go with? The null hypothesis or the alternative hypothesis?
Alternative.
Yeah, alternative. Thank you. A couple people there. Thank you. Because it doesn't have the possibility of equality. So it's going to be sigma is less than 10. And then up here, what's the opposite of less than 10?
Greater or equal to.
Yeah, greater than or equal to. Remember, this always has to have the possibility of equality, so greater than or equal to 10. Are you okay with that one? You want one more like this, setting up the null and alternative hypothesis? It's up to you. Going once.
I think we're good.
Twice, gone. All right. So we're good. Now, what we're going to need to do is decide, we need to decide which one of these we think is right. And that's going to mean setting up a hypothesis test and testing things with, a lot of different ways, but amongst other things, you can test it with a p-value. So let me discuss a p-value. And then we'll look at finding p-values. P-value is the probability that the null hypothesis, so H sub 0, is true given the data in your sample. So you collect some data and you take a look at it and try and make some decisions on whether or not you think H0 is true or false. That data is going to provide you with a probability, the probability that this could be true relative to your given data. And then we're going to have to decide what to do about this. Are we going to reject it, or are we going to accept it, etc. Now, to calculate a p-value, you're going to need to get some areas underneath the standard normal curve or other curves. But at least initially, we're going to just work with the standard normal curve. So let's look at p-values. Once again, this should be stuff on your handout. And I tried to kind of black it out here a little bit. Let me do a better job. Let's just get rid of those. Our p-values are going to be areas in the tail of your distribution. Now I'm starting out with a normal distribution, but we could do this for other distributions. You're going to have a left tail p-value if your alternative hypothesis looks something like this. And I don't want to write a mu there. I want to write a p. This p is going to be less than some number. If you have HA such that p is greater than some number, then you're going to have a right tail. And if you have p is not equal to some number, I'm using the hashtag for some number, then you're going to have a two-tailed test. So the p-value is in part determined by the shape of your null or your alternative hypothesis. Now, one thing I want to point out is that this left tail, right tail, and two-tail stuff depends on p must be on the left side. Be on the left. That's where this works, that The inequality points in the direction of the area that you need to find. So let's do a few examples. And let me scroll down here. Is this one? I don't know. Yeah. Scroll down to this one down here. Now I scratched out this, at least on mine. Not sure if it's scratched out on yours. I hope it is. But we've got an observed test statistic of z equals negative 2.39. This is something that your calculator or your software will give to you. And we want to find the p-value corresponding to that. And that's going to be part of a claim or testing a claim of p is less than 0.19. So let me pull all this together here. I'll call this example D. And let's start with that claim. That claim is that p is less than 0.19. Is that part of the null hypothesis or alternative hypothesis?
Alternative.
Yeah, that has to be part of the alternative hypothesis because it doesn't have the possibility of equality. Thank you, well done. How about the null hypothesis? If this is our alternative, what has to be here in the null? Well, the opposite of less than would be greater than, but you know that the null hypothesis also has to have equality. So it has to be greater than or equal to. Now, as one last reminder here, it's probably p equals 0.19 in my math lab. That's okay. Can anyone tell me what tail test this is going to be? Left tail, right tail, or two tail?
Left.
Based on the alternative. I'm sorry, what was that again?
Left tail.
Yeah, that's going to be your left tail test. So here's what we want to do. We want to find the area to the left of our z statistic underneath the normal curve. All right, so let's draw ourselves a nice normal curve. So that's 0. And our z statistic that was given to us was z equals negative 2.39. Now that's going to be out here someplace. And for a left tail test, the p-value is going to come from the area in the left tail. So it's going to be how much area is to the left of that value. You can find this with Google Sheets. You can find it with your graphing calculator. Because we're in that part of the course, more and more I'm just going to be using Statistic. So let me show you how to do it there. So let's see, Statistic. Within Statistic, go to Analysis, then Probability Distribution, then Normal Distribution. And I'll kind of see if I can't squeeze that into my notes. So Statistic. So Analysis. Probability Distribution.
We can't see our notes, by the way.
Okay, no, it's all right. I'm not displaying that right now. But I appreciate that. And then Normal Distribution. So there we go. Statistic, Analysis, Probability Distribution, and then select Normal Distribution. So menu, submenu, and then selection on that submenu. Okay. So let's see where that takes us in Statistic. So I want analysis, probability distribution, normal distribution. It takes me here, and I've got a z-value of -2.39. So let me type that in, then hit evaluate. Now, do I expect a big area here? Do I expect a lot of area to the left of 2.39? Probably not, because most of the area is going to be around 0, and we're a couple standard deviations away, so I don't expect a big number. And if that was my expectation, I'm not going to be disappointed. The area to the left of that is 0.0842. Actually, 0.00842. And that's your p-value. P-value. Yay. Were you able to get that p-value out of Statistic?
Yep.
Yep.
Okay.
Yep.
Perfect. Thank you. Let me change up this one just a little bit, and we'll see what kind of difference it makes. It'll also let me do another example kind of on the cheap without having to do too much work. So what if I change the alternative hypothesis? So I'll call this one example E. So for example E, let's do this. Our claim is going to be that P equals 0.19, like that. That kind of changes a lot. We're still going to have the same Z statistic, Z equals -2.39, but we'll see what effect that new claim has on our work. That new claim has to be part of the null hypothesis, so that's P equals 0.19. What does the alternative hypothesis have to be?
Does not equal.
Yeah, thanks, Ella. Does not equal. So what tail test is this?
Two-tail.
Two-tail. Well done. This is a two-tail test. So let's take a look at that. And draw ourselves another normal curve. There we go. So this time I want to find the area to the left of -2.39 and to the right of 2.39. So do I have to do a whole lot more work? Well, I already know one of these areas, right? I already know that this is 0.00842. So I've got that area. How about this area? Can anyone tell me without looking at Statistic what the area is? Say again?
Would it be the complement of it?
Not quite. So the complement would be 1 minus that, and that would give you the area to the right of that. So, I mean, I think you're heading in the right direction, but
.00.
Pretty much actually be the same.
yeah, it's just, remember, the thing about the normal distribution is that it's symmetric. So it's going to be exactly the same, 0.00842. So if I wanted the p-value for a two-tail test like this, then really I just got to add these up. So the p-value is going to be 0.00842 plus 0.00842, or you can multiply it by 2, and that would give you the same thing, 0.1684. Now, fortunately for us, Statistics has a little tolerance in it, because that's not the only way that you could get this, although it's certainly a convenient way to get it. What if you're just looking at the stat disk? Do you see anything else that might be helpful from stat disk?
It says two-tailed.
Yeah, gives you the two-tail. But if you notice, we picked up a little bit of extra area, probably because it wasn't rounding as much until the very end. So if I was giving this on a test, certainly I would accept a couple different values, 0.01685 being one of them. Okay. How's that one looking? Doing okay on that one? Should we do one more like that? Let me see if I got one handy. If I do, we will. Yeah, let's do this one last one down here. So we'll call this example F. So we've got a test statistic of Z equals 1.18. Actually, yeah. I guess, we already did one not equal to. Let's go down to this one. Test statistic of Z equals 1.79. And we're going to use that in testing the claim of P is greater than 0.20. Now that P is greater than 0.20 or 0.2, that has to be part of which hypothesis? Some help there? What hypothesis is that part of?
No.
Yeah, the null. Thanks, Jess. So what is it? What do we need though to be part of the null? Jess, what does this have to be part of the null?
Normally we'd have the equal to.
Yeah, it has to have the equal to. So if it doesn't have the possibility of equality one way or another, one of those three, then it has to be in the alternative one. So that was going to go in the alternative. If P is greater than 0.2 is in your alternative, what has to be part of the null then?
Less
What's
than or
symbol?
equal.
Yes, well done. Less than or equal to. Okay. Someone new here. What tail test is this going to be? Left tail, right tail, or two tail?
Right tail.
Right tail. Thank you, Sarah. So, it's a right tail test. And I like to draw a little diagram so we kind of keep track of things. Okay. And let's fill this in. Straight down the middle is a 0. And our Z value here is 1.79. So not quite 2 standard deviations away from the mean. Remember, this has a distribution Z is distributed normally with a mean of 0 and a standard deviation of 1. So you're not quite 2 standard deviations away from the mean, but you're certainly up there. And I don't expect
Really?
to be a lot of area here to the right of that.
Really quickly, we won't ever get one of these values that won't be a normal distribution, will we?
Oh, yes. Yes, you will.
Okay.
Well, we'll get chi-square distributions, t distributions, f distributions, a lot of stuff. But the good news for you, in case you're worried about it, is that there's plenty of software around to help you look that up. Now, in
Okay.
the olden days, you had to do that by hand. You had to take out your chart, and then you'd look up 1.79. So it would look like this. The first two values would be in the left column, 1.7. So I come down to here, and then I gotta go all the way across underneath to get to 1.79. And then I gotta realize that this is the area to the left, and I gotta subtract and get the area to the right. Yeah, have fun with that. I don't think so. So, but we're gonna do those, we're gonna do it with some software. And this time, you know, I'll remind you on how to get there. It's analysis, probability distributions, and then normal distribution. We'll type in 1.79.
The process is the same, though. Yes,
The
essentially.
probability would be the same. In fact, if you looked at my sheet here, the one I had here just a minute ago, and if we did 1 minus that, let's see, you know, this is a chi-square distribution, but we did 1 minus the sheet that I just had out, then we'd end up with the correct probability. It's just a little easier here. It just tells you the right probability. Question is, can you see it? What's our p-value here? Which one of these numbers do I want? Am I expecting
The
a big
right
number
side?
like this? Probably not. Somebody said it. What was it?
The right tail.
Yeah, the right tail. That's the one we want. And if you look at the number there, 0.0367, 0.0367, at least it makes sense. You didn't expect a big number because we're kind of far out in the right tail. So that number looks suitably small. All right. Looking good there. Looking good. Questions on that? Are you comfortable finding these p-values? Of course, now that we found them, we need to have something that we're going to do with them. What we're going to do with them is use them to help decide if we're going to accept or reject a null hypothesis. And as we do that, we're going to make the decision to accept or reject. Now, we'll get more practice accepting and rejecting based on the p-value in section 8.2. But for now, are we comfortable with finding these p-values and setting up our null and alternative hypothesis?
Yep.
Yes.
Okay, cool. Well, I'm going to stop the video here, and we'll do a part 2.